All right, the dreaded 19.2, right? Okay, so remember the first thing you do with this is you want to reduce this circuit until it's a solvable circuit. Now we can solve parallel and we can solve series circuits, right? That's all we know how to solve. So first thing to do is to put these guys together, right? So 9 and 8 is 17. That's series, you just add them up, right? And then these guys, since see their ends are connected together, these guys are parallel. Okay, so that's going to be 17 and 19 in parallel, right? So 17 to the minus 1 plus 19 to the minus 1 to the minus 1. Parentheses, 17 to the minus 1. I'm using the button to the minus 1 on my TI-84 calculator. Plus 19 to the minus 1, minus 1. 8.97222222 ohms, right? And then we've got another series. We've got this, then the 8.972 and the 6 and the 5, right? Okay, so that's going to be 4 plus 8.972 plus 6 plus 5. Okay, so plus 4 plus 5 plus 6. 4, 5, 6, and then that, yeah. And that's 23.97222. And then notice that that's in parallel with a 13, and then suddenly this thing becomes solvable, right? Oh, my hand slipped. So this is going to be 13 to the minus 1 plus 23.9 to the minus 1. Okay. So parentheses. 13 to the minus 1 plus, I'm just going up arrow and hitting that guy to the minus 1 to the minus 1. 8.429, almost exactly, ohms, right? Okay, so now I've got a sweet little series circuit. Just ignore them. Remember, this is, it looks all scary, but just remember, just think of this as just one common everyday available 8.429 ohm resistor, right? Okay, so my one current in this circuit is 57, right? Divided by 5 plus 8.429 plus 3, right? That's what we do, right? It's the voltage divided by 5, this, and this, right? So 57 divided by parentheses 5 plus the number I just got plus 3, and that's 3.469. Ta-da! And there you go. I've got that. All right, this is good. This is all very good. I'm checking my answers here as I go because I don't want to make a video that's like, oh, I got the wrong answer on the first step. Okay, so there, that's our first thing. This is good. And what I'm going to do on the assessment is I'm going to actually give you this value. I'm going to put it in there rounded to 3 sig figs. If you can't get A1, try a couple times, but there's no use spending 20 minutes figuring out the rest of it if you can't get A1, right? Okay, so now I'll give you this clue. I'll always put voltmeters where voltmeters need to be. I'll also put them places where they don't need to be, right? But if there's ever a sub-circuit, and this definitely is not just one resistor, it's many, I'll always find that voltage across that one, right? So V1 is IR, okay? So It's just a series circuit. Remember, just don't let this intimidate you, right? And so our current is 3.469, and our resistance is 8.429. Okay, so I'm going to take that number times that number, and I've got this 29.244, right? And that is also the right answer. Okay, this is very good stuff. Okay, so now I can find V2. V2 is IR. This is not, by the way, an essential number, okay? V2 is IR, and so that's going to be, oh, yeah, I can do this, okay? Oh, no, I can't do that yet. Can't do that yet. Okay, so what I want to do is I want to find this current in here, right? Okay, and this is a parallel circuit. I've got V2, right? And it's pushing current through the 13 ohm resistor, right? And I've got V2 is also pushing current through the 4 ohm and this complicated thing in these guys, right? Okay, so I think what I'm going to do is I'm going to find the current through the 13 ohm. Let's do that first. Okay, so I is V over R, right? So that's going to be 29.244. This is, by the way, the current in the 13 ohm, right? You'll see why that's important in a sec, right? And then our resistance is 13. Actually, that's not important. This current's important. Okay, so I'm going to go that answer divided by 13. And I get 2.24955. So I'm going to round that. We're not going to use 2.25. Okay, and that is, yes, our current. Okay, that's good. Okay, so next thing, the next thing we want to find is the current through the 4 ohm. That's going to be cool. Okay, so let's see. I, for the 4 ohm, is V over R, and that's going to be 29.244 divided by all the resistance in this loop, yeah? Right, so it's 4 plus this, plus this, plus this, which we figured out was 23.972222, right? If you forgot that, go 4 plus 8.972222 plus 11, right? Okay, so 23.9722. Okay, so here we go. I'm finding the 29.244 divided by the 23.972222. I'm going to find that number. I'm going up arrow, up arrow. I've got to keep going. Oh, there it is. Okay. And I'm getting 1.2199. Okay, and that is my current through the 4 ohm. All right. Yes. Okay, now I've got the ability to, let's see, 9 ohm. I can't pick that off. The 19 ohm, I can't pick that off. But now I can find V3, right? Because I know that that current, this 1.2199, is going through the 4. It's also the current going through the 5 and the 6. But don't forget, it's also the current going through this one resistor. We're pretending it's one resistor with this value, right? Okay. So I can find V3 now. Okay, V3 is equal to IR. And our current is this 1.2199 times 8.97222. Okay, so I'm going to take that number times, we're going to go find the 8.9722222. There it is. 10.945. Okay, so that is my V3. Oh, we skipped V2. Let's see. V2 is over the 4 ohm, right? So V2 is going to be IR, right? And we figured out that that current through the 4 ohm is 1.2199, right? Because it was V1 divided by all of this resistance, right? Okay. Yeah, there we go. Okay, so that is 1.2199 times 4. So I'm finding there's the 1.2199, not rounded, right, times 4. And I get 4.8796. And I'll say 97 just for fun. 8797. Let's see, V2, 4.8797, sure. I'm just checking my answers as I go here on the sheet. Okay. So, and we've got this voltage here. Okay, this V3 now is across these guys, right? That's the voltage from here to here, right? Okay, so now I can find the current through the 9 ohm, right? Okay, I've got 10.9454 volts across 17 ohms of resistance. Remember, this is now a parallel circuit. We can solve parallel circuits, right? So this current through the 8 and the 9, it's just one current, right, is, so the current for the 8 ohm and the 9 ohm, right, is equal to the voltage that's across them, right, V over R. So it's 10.9454 divided by 8 plus 9, right? Because it's that voltage and it's a series circuit. So I take that 10.94 whatever, right? Divide by parentheses 8 plus 9. Or I could be clever and divide by 17, right? And I get that that is 0.6438 amperes of current. All right, and then let's find the 19 ohm one. I don't have any space left. There's no space. All right, I can do it right here. Okay, that's going to be the same thing, right? It's the same voltage as across the 19 ohm, right? Right, so that's going to be 10.9454 divided by 19. Okay, that's going to be the current through the 19 ohm, right? Okay, so let's find that. 10.94 divided by 19. And I get 0.5761. All right, I think I got all these right. Let me just make sure I don't have the wrong. So let's see, V2 is 4.87. V3 is 10.94, yep. V1 is 29.24. A1 is 3.469. Yeah, I think we're good. We're good. All right, so reduce the circuit till you can solve it. Solve it, and then you want to find the voltages across the reduced parts. Use those to break out the parts that are reduced, and then, yeah. All right.